Hey everyone, welcome to this explainer. Look, if you've ever stared at a math problem and thought, wait, why did the alphabet just crash the numbers party? You are definitely not alone. Algebra can seem incredibly intimidating at first glance, but I'm here to promise you something today. I am going to show you a foolproof, super easy method to master adding and subtracting algebraic expressions. We'll walk through every single detail, step by step, so that by the time we wrap up, you will have absolutely zero doubts. Let's conquer this together.
Here's our clear, step-by-step game plan for today. First, we'll look at algebra's basic building blocks. Then we'll practice spotting the like terms. Third, we'll tackle adding expressions two ways. Fourth is subtraction and the sign flip. And finally, solving complex problems together. All right, let's jump right into part one, algebra's basic building blocks. To be truly successful in algebra, we really need to make sure we're all speaking the exact same language. It's the most common question I get. Letters mixed with numbers? Where do we even start? It honestly feels like trying to read a completely foreign language. But actually, scratch that. It's way simpler. These letters aren't there to trip you up. They're really just empty boxes waiting to be filled with a number we don't know yet. Once you realize they are just placeholders, the fear completely disappears. So let's meet the main characters of our algebra story. First up is the variable. This is your letter, like an X or a Y, and it represents that changing or unknown value. Right next to it is the coefficient. That's the number sitting directly in front of the variable, basically multiplying it. So if you see 4x, 4 is your coefficient. And finally, the constant. This is a fixed number that just chills completely on its own, like a 5, a 25, or a 100. Put a coefficient and a variable together, and boom, you've created what we call a term. Now here's where it gets kind of fun. It's incredibly simple to categorize these algebraic expressions. You literally just count the terms. And remember, terms are always separated by a plus or a minus sign. If an expression has just one term, like 4x, it's a monomial. Two terms? That's a binomial. Think of a bicycle with two wheels. Three terms make a trinomial. And the big umbrella category for anything with one or more terms is a polynomial. It's really just a simple counting game. Okay, moving straight along to section 2, spotting the like terms. Now that we've got the vocab down, you are totally ready for the single biggest secret in all of algebra, spotting like terms. Like terms have the exact same algebraic DNA, meaning the exact same variables and exponents. Take a look at 3xy and 8xy. They both have an x and a y, so yep, they're like terms. But over on the flip side, we have unlike terms, like 2x and 4y. Because x and y are totally different variables, they're completely distinct. You just can't mix them together. And that brings us to this. And please burn this into your memory. The golden rule of algebra is, you can only combine like terms. Seriously, you cannot add an x to a y any more than you can add apples to oranges. If their variable parts don't match up exactly, you just leave them alone. Full stop. So let's put that rule to work in section 3, adding expressions two ways. With the golden rules safely in our tool belt, let's try our first strategy, the horizontal method. Step 1, you write the whole problem out horizontally in one long line, linking the expressions with a plus sign. Step 2, you play matchmaker and gather all the matching like terms so they're sitting right next to each other. And step 3, you simply add their front numbers, the numerical coefficients. The most important thing here, the variable parts stay completely untouched. Just like adding 3 apples and 2 apples gives you 5 apples, right? Not 5 super apples. Let's see this in action with a real example. We're adding 3xy plus 7yz and 8xy plus 5yz. First up, we group those like terms. We slide our xy terms together, giving us 3xy plus 8xy. Then we gather our yz terms, 7yz plus 5yz. Next, just add those coefficients. 3 plus 8 gives us 11xy, and 7 plus 5 gives us 12yz. So our final answer is 11xy plus 12yz. Pretty straightforward, right? But hey, what if your brain just prefers things stacked up neatly? Well, that is exactly where option 2, the column method, shines. This is a fantastic alternative if you like keeping things visually organized. You just write down the first expression and then write the second one directly below it, making absolutely sure those matching like terms are perfectly stacked in vertical columns. Then you just add straight down. Look at how beautifully this lines up. We're actually adding 3 expressions here. On the left, we've stacked all the x terms, 4x, 8x, and negative 6x. On the right, all our constants, 3, 9, and negative 5. We literally just read down the column. 4 plus 8 is 12, minus 6 leaves us with 6x. Over in the constants column, 3 plus 9 is 12, minus 5 is 7. So our nice, tidy final answer is just 6x plus 7.
All right, doing great. Now for section 4, subtraction and the sign flip.
So let's pivot over to subtraction. I know, subtraction usually makes people a little nervous, but I promise you it is exactly as easy as addition. It just requires one absolutely crucial trick before you start grouping your terms. I like to call it the invisible -1. Whenever you face a subtraction problem, there's a minus sign hiding just outside the second set of parentheses. And that minus sign, it's actually a sneaky, invisible -1 just waiting to do its job.
You see, in algebra, if a variable doesn't have a number in front of it, its coefficient is just a 1. And when you drop a minus sign right in front of a bracket, it means you're taking that -1 and distributing it, literally multiplying it, by every single term sitting inside that bracket.
So here is the golden takeaway for this part. When you're subtracting, always flip the sign of everything in that second set of parentheses. Every positive term turns negative, and every negative term instantly flips to positive. The best part? Once you do that quick flip, it just becomes a regular, easy addition problem. Let's visualize this. Before the flip, we've got a minus sign outside a bracket with 3x minus y inside. We distribute that invisible -1. The positive 3x, boom, it becomes a -3x. The minus y, it flips to a plus y. So after the flip, we drop the brackets entirely, and we're left with -3x plus y. This step is a total game changer. If you remember the sign flip, I guarantee you will never get a subtraction problem wrong. Which leads us perfectly into our final part, Section 5, Solving Complex Problems Together. Look at how far you've come. You know the vocab, you've mastered the golden rule, and you know the magic sign flip. So let's take on our final boss equation, 5x plus 7 minus 3x minus 2. Take a deep breath here. Do not let this intimidate you. You already have every single tool you need right in your brain to solve this flawlessly. Step 1, we open those brackets. Now the first bracket, the 5x plus 7, doesn't have anything in front of it, so it just drops straight down, completely unchanged. But that second bracket has a minus sign. Time for the sign flip. The positive 3x becomes a -3x, the -2 flips to a positive 2. So our brand new, much friendlier equation is 5x plus 7 minus 3x plus 2. And this brilliantly sets us up for step 2, grouping like terms. We grab our x's and wrangle them together, which gives us 5x minus 3x. Then we grab our constants and put them together, 7 plus 2. Well, 5x minus 3x leaves us with 2x, and 7 plus 2 is 9. Put them side by side, and there it is, our perfect, fully simplified answer, 2x plus 9. See how incredibly manageable this becomes? Algebra really isn't magic, and it's definitely not trying to trick you. It's just a system. It's all about following a few simple logical steps. When you respect the golden rule of like terms and remember to do your sign flip for subtraction, honestly, the math practically does itself. Look at what you've accomplished in just a short time. You've completely cracked the code of mixing letters and numbers. Just group your terms, watch those signs, and show that equation exactly who is in charge. But you know, what happens when you have to start multiplying all these terms together? Well, that changes the game entirely. But that is a puzzle for next time. Keep practicing, and I'll see you in the next explainer.